So, welcome everybody. It's the 4th of February, 2025, and this is the Open Research Institute Field Programmable Gate Array status meeting or stand up meeting. And so, we do is we talk about what we've done over the past week or so, what we have planned for the next bit of time, if we have any roadblocks that are getting in our way, if we need help with anything, and if we need any resources, there's something that we need in order to get things done. And welcome, hey, welcome to Aaron. And I know that you may have some time constraints, so why don't you go ahead and start us off today to Aaron?
Sure. Thank you. So what I've been working on is I've been using the ZC706, and I've implemented OpenCPI on it with the FM Comms 3 transceiver on it. And the reason that I've been doing that is because I want to enable the 9371. So now that the board is up and running within the OpenCPI framework, and I can run our reference applications. Right now, I had the an FSK modem implemented on it on the hardware successfully. Then since it's known working, I can begin implementing the 9371 work onto that platform as a transceiver. So the goal with that is since the 9371 utilizes the JESD 204 interface, that some of that work will be applicable to the ADRV 9009 as well, to get a beefier FPGA with a beefier transceiver set for the high Faria platform. So that's what I've been working on. I did work on a little bit with the so that's what I'm going to be working on. I did spend a little time with the MSK modem. I've updated it to a more recent version, and I've gotten what in OpenCPI they're called workers building, but I haven't gotten to the point where I can simulate to see how things are working yet. But I plan on doing that as well. That's what I've been working on lately for the project. No blockers, or I don't need anything. And I've been on Slack and seeing the progress you guys are making, which is great. Thanks.
Well, thank you. That's tremendous. And just to let people know, where's the best place to learn about OpenCPI?
So at OpenCPI, the best place, there are various places, but the main, I guess, entry point would be opencpi.org. That's our website. And then from there, you can go to our GitLab project. There's a community forum as well that I'm a part of. But if you have any questions about it, just feel free to ask me and I'll be able to answer it.
Yeah, thank you so much. Okay. Hey, Matthew, why don't you go ahead and take the floor?
All right. Thank you. So this last week, it's been a little more slow on progress, but I have the moving, the exponential moving average filter integrated into the MSK top, as well as the complex IQ outputs are there. And again, it's kind of a really simple complex IQ approach in that we generate from the NCO a sine and a cosine. And so instead of just modulating, say, the sine output and putting that on the I channel, I'm modulating both the sine and the cosine and putting the sine on the I channel and the cosine on the Q channel, or whichever way it was. So it was a simple way to get the complex IQ outputs. Let's see, there was something else. So I said I integrated the exponential moving average, but that's not quite right, because that was part of the power detector. So I had integrated the power detector, which is what I actually had done. And I think there was something else I integrated, but I can't remember what it was. I was just trying to look in the Slack channel to see, but it might be too far back for me to find easily.
Was it about the preamble or the tones? I think that you.
Oh yeah, thank you. Yeah, I just set it up rather than having the preamble, since there's maybe some question about if we can generate the preamble easily, but another way to get the loops to lock quickly is to just transmit a tone, because the Costas loop should lock to the tone, would make it much easier for it to lock to the tone versus like having a modulated signal. So I just have we can transmit an F1 tone, transmit an F2 tone. We could transmit them both at the same time. I thought, so then both loops, assuming that the two loops can work with the other tone present, then, if that was the case, and I haven't simulated it yet, but the idea being then both loops would lock at the same time. So it should reduce the overall lock time, because you get the F1 and F2. They both be receiving tones at the same time. Otherwise, like, we'd have to interleave some tone, some time of tone on the F1, some time on F2, and then kind of go back and forth, which is what the modulated waveform would do. But I'm hoping if we can, that they'll be tolerant of the other tone, and then the idea being we should be able to lock those loops in the minimum amount of time. So my next steps would then be just simulating the top level, making sure that the power power detector is integrated properly and is detecting correctly. And then the other thing is just testing the tones and seeing that we synchronize to them, and whether or not we can transmit both at the same time. And then the power detector, I ran across an approach where we can estimate the actual power. So, the power is I squared plus Q squared, square root. And so can't really do a square root in hardware, at least not easily. So there's a way you can estimate the square root based on the magnitude of I and magnitude of Q. And so I'd like to implement that. So right now, when we read back the power, it'll be the square of the power. So software would have to do the square root, but we can modify it so that we have this estimate of the square root values. When we read it back, we're just getting that estimate. Software would still have to do the conversion to dB or dBFS by doing the log P over P, log 10 P over P type computation. So that's everything that's done and kind of pending. And then as we have to review again what is probably on the next steps as we go forward, but I probably won't get to any of that before next week, so we can discuss again next week. I think that was all I had.
That's a lot. Yeah, it's three big integrations for the HDL code, and yeah, we'll just look for for things
Oh,
happening
well,
over. Oh, go ahead.
I was just going to say one comment. I've been having to learn system Verilog of late, and so we were thinking about maybe converting the MSK to system Verilog. And one of the things I've run into is system Verilog is horrible at math compared to VHDL. In that when you do an add, it doesn't sign extend the adds. You have to like pre-sign extend the signals before you add, so that it or even a multiply, so that you get the prop, so you can address the bit growth. And it's been really killing me trying to get the math working right in system Verilog. So I don't know, it's just kind of a thought and a comment. It's not necessarily here nor there, but as we're converting, that would be something to keep in mind. But which reminds me though, is I'd like to start seeing that we add some like UVM or in the cocotb more, some constrained random testing for these blocks, so that we can they're more amenable to a simple or more straightforward regression process, as well as you can potentially do a CI flow with them in the future if we wanted. So I think that would be another thing that would be good to start developing some UVM testing for the individual blocks, and then even for the entire modem chains.
Yeah, I think that's a really good idea. I can add that to the help wanted section,
Okay, yeah.
and and then we
And I
can.
should add that to the Trello board too.
That's a yeah, that would yeah. I actually rated the Trello board for a lot of the help wanted, and then kind of went around and asked any of the leads if they had a task that they thought would be a really good, like onboarding, on ramping, something that was relatively standalone but meaty enough to be of interest to somebody that wanted to, um, you know, share their time with us. So yeah, the adding that would be good. It'd be excellent because then the things, I mean, our goal is for this to be reusable, and um, to having here. By the way, here's not just the source code. Here we can prove that that works. Here's how you would test it. So
Mhm.
those are super important. So yeah, I'll do that. Awesome. Okay. Well, Pete, you have the floor.
Oh, I don't have anything. I'm just finding out what's going on and who's who here. So thanks.
Oh, of course, yeah. Well, I, I'll introduce myself. So I'm founder and currently CEO of Open Research Institute, and my job is to help projects be successful and help people be successful doing projects. My main area of interest is information theory and digital signal processing, digital design. Um, any connection to that, I'm very interested. Algorithm design, protocol design. And yeah, digital communications of any type. I do a lot of regulatory work to try to clear the path for folks to be able to volunteer and to do open source work. So there's a significant amount of regulatory work that has happened over the past couple of years we've been involved with and continue to try to be involved with. To me, they go hand in hand. So that's kind of my role. Here to help people get the most out of open source for any number of reasons, whether it's just a personal wish to develop their skills, or if they want professional development, they want to get further ahead, in their professional life, and also education. So we are available and have helped lots of students along the way get a little further along or a little more comfortable, giving them some practical projects to take on and sort of like put that into action. So we've seen a number of people go on to get either do better in school at the university level, get master's degrees, and we've been able to help several people get into PhD programs with either providing some references for them, like reference letters, and also to give them a good project experience that helped them along the way. So that's kind of the span of why we're doing this. And then Matthew, you probably want to introduce yourself.
Oh, sure. I'm Matthew Wishick, person. Um, I've been a digital design engineer for 25 plus years. I worked in a PC manufacturer out of college, EverX, if anybody remembers back in the older computer days. And then spent some time at TRW on the F-22 fighter, and then Nokia mobile phones. And then for the last 20 plus years at a broadband communications equipment manufacturer, designing ASICs and broadband modems and and systems developed from those broadband modems. So that's kind of my experience. I got involved with ORI last year, about a year ago, and it's really exciting. I really enjoy the projects we're working on and the mission of the organization. Um, anyway, so I think that's kind of a little bit about who I am.
So Aaron, if you have some time to introduce yourself, that'd be wonderful.
Sure. Good to meet you, Pete. I'm Aaron Olivares. I've been working in this with FPGAs and specifically software-defined radios for about 10 years now, a little bit more than that. I got involved with the open source project called OpenCPI. I'm currently leading that effort. And some of the interests that I have, well, one of the things that it does is allows you to build your application, software-defined radio application, and port it across different pieces of hardware. And wanted to get this is an opportunity to work with ORI and to show off its capabilities. We're not there yet. We're still in the early stages working that way. But my background's in computer engineering. So embedded systems, FPGA software-defined radios is kind of what I like to do. And I do that professionally, and I also like to do it in my spare time. So that's why I'm here.
And then Pete, why don't you go ahead and tell us a little bit more about yourself, and then if you have any particular interests or anything that you would like to know more about.
Thanks. Yeah, I'm trying to add up in my head. I think I've been at Ham now for 35 years. And basically, I love all things signal processing, communication, stuff like that. So anything signal processing, and sort of always interested in mixed signal hardware and that type of thing as well. And right now, my kind of side hustle project is trying to build a really simple classy HF single sideband transmitter. Having a very power efficient amp for portable QRP operation. And so that's kind of what I'm up to.
Very cool. And then let's see, I think we have another person on the call. This is Rick Hambley. Rick, you want to briefly introduce yourself and maybe say a little bit about DSES?
Good thing. So I'm Richard Hambley, and I've been involved in communications since about 1959. I have worked for many companies designing digital communication systems and related things. I now run my own company that's primarily involved with precision time and frequency products, but ham radio is still the core of everything I've ever done commercially. And so to keep busy while I'm not trying to earn a living, I'm on the board of directors of the Deep Space Exploration Society, which is that dish that was in the background when I shut off my video. We have a modest little 60-foot radio telescope dish that does both transmitting and receiving for both ham radio and science. And we look for pulsars, and we've recently detected our first magnetar. We were really excited about that. And I enjoy doing that because I also am involved with NASA's activities in the same arena. The Very Long Baseline Interferometry System and the VGOS system, and I teach classes at Haystack Observatory, which is coming up again in April. I'm not sure if I'm going to go this year or not. We'll see. Anyway, the Deep Space Exploration Society has ramped up its activities dramatically in the last couple of years. And just this week, we published our annual report of what we did this year. And if anyone's interested, they can find it at the website dses.science. And we're trying to keep all of our papers and progress there. And our new project, which we're getting ready to execute very soon is digital communications by bouncing signals off Venus. Moon bounce is too easy when you have a 60-foot dish. So we're going to try Venus. And there's some papers online about how we're going about doing that. But we're basically putting a full E down 1.5 kilowatts at 1296 into the 60-foot dish. That's 1.5 kilowatts times 45 dB gain. You don't want to stand in front of it when we're doing that. And all the hardware is built and will be installed and tested within a matter of weeks now. So if anyone's interested in coming out to see what we're doing, contact me and I can arrange to get you out to the site. It is a short drive east of Colorado Springs in Colorado, in Haswell, Colorado. All you do is get on Route 94, go 45 minutes straight east, then turn right, go 45 minutes south, then turn left, go 45 minutes east, and you're there. No stoplights, just stop signs. It is in the middle of nowhere, which is where it should be for a space telescope. Anyhow, that's what I have for today.
Very good. Thank you. Yeah, I think we're looking forward to EVE, EVE, or Earth, Venus, Earth. That's going to be a really neat thing to see happen. Let's see. So let's, over the past week, I've been working on the MSK a little bit in the lab there, and we're looking at over the air performance. So we're starting to see some traction over the air. We have digital loopback working for the Opulent Voice MSK implementation, pretty solid. And when we go out to the transmitter and receiver, this is conductively coupled back to the same radio. Things are working really good. When we attempt to go from one radio to the other, limited success, but we are looking at all sorts of different ways to try to narrow it down exactly what's going on. The complex IQ may actually help here if we're experiencing some sort of image interference, because we do have fairly wide filters right now for the transceiver. So doing a lot of work in the lab, bringing some of the artificial intelligence transceiver work up to date, because I am scheduled to give a presentation to a really nice amateur radio group about artificial intelligence applications in amateur radio. So there's what we picked as our kind of first attempt was RTTY, or radio teletype demodulator decoder, which works surprisingly well. So that's going back through all the code and seeing where the next steps are to give a presentation to a really nice group. And we're continuing to kind of strengthen our ties with IEEE and to continue to kind of like start to co-host and co-sponsor more events through IEEE. We're involved with one of the standards societies, but the meetings have tapered off a little bit. There's a drone wireless data sort of standards committee that we got involved with. So we're now looking kind of around to see if there's any of the others that might look good from an open source perspective. So things like that. So over the next week, hoping to get a lot more time in the lab to help out with Opulent Voice, and to also continue to help Ken Easton out with getting the other side of the connection going. This would be the receiver in the spacecraft, or ground sat, as we call the terrestrial central node. So things are progressing there. We have made some progress in moving from Petalinux based implementation to more of a pure Yocto layers approach. So that's some forward steps there. I don't really think that we've gotten to the point where we have a bootable image, so we have not equaled our previous success with Petalinux. So that's a little bit of what's going on. Remote Labs is doing well. There's been an update to the main server, so we use a fairly large machine with what's called Unraid. And what Unraid does is it provides support for virtual machines. That's its job. This is Unraid server, very sort of a popular solution in the gaming community. So where you can have your tuned gaming experience on a virtual machine, but then switch back to your generic general purpose machine more quickly. We found that it works really pretty well for setting up virtual machines, and then you assign your lab hardware, your SDR, to one of those virtual machines. This resolves a lot of the problems that we traditionally have with virtual machines not playing entirely well with actual hardware. So that's kind of the heart of our remote labs setup. So we did have a pretty major update to the Unraid server. Things apparently going well for me. So all the tests rang out. So the upgrade went well. And that's what I've got. All right. Any other comments or questions before we close for the day?
The only comment I had was, were you able to run any tests as far as setting up a different clock on the Plutos in the lab in order to get synchronize the carrier?
I'm not sure where that test is, but I'll ask Paul to speak about it on Slack.
Okay. All right.
Yeah, very good. Well, thank you, everybody. Oh, go ahead, Matthew.
Oh, I was just thinking that in the over-the-air testing, that's working pretty well. We just have that 0.4% error rate, but we are locking in the presence of a frequency offset and even frequency drift. Paul had posted some pictures or images in the Slack channel of the oscillator drift on the Pluto. So even in the presence of that drift, the receiver seems to be locking and tracking the over-the-air receiver just with that 0.4% error rate. That is the new weirdness that we'll figure out.
Yeah, it's very interesting that when I was working on the MSK CPU implementation, that I was able to get it to work, and I had a similar error rate where I couldn't get perfect 0%, but I got a small, I think it was like 0.1 when I was working with the CPU implementation. It might be, well, I don't know. It has to be possible to get it down all the way to 0. I mean, and especially in these RF
in the
and cable
analog
connection.
loopback, we're 0, right?
Yeah.
So it's just the unit that's not 0, and leads me to believe it really has to be frequency offset. But yeah, that's it's a odd thing.
Yeah, it is.
Yeah, I think we'll dig in. We'll dig in this week again, and we'll take another good hard look at it, and hopefully we'll have all sorts of stuff to talk about next week. Also, very soon, our January newsletter will be coming out. So that the draft has been submitted to the board for review, and then right after that goes out, within the next day or so, hopefully, we'll be starting on the February newsletter. So if you have something that you want to share or talk about, spread the word about, please consider our newsletter. So we're trying to get one out a month. Or so. And so far, it's been very well received. We've got good feedback. So January newsletter coming out soon. February newsletter will start right after that. All right, everybody. Any last comments? All right. Well, thank you, everybody, so much for your time. Because, once you spend time, you can't get it back. So it's therefore priceless. Very appreciated around here. And yeah, please check out all the repositories on GitHub. And we'll have a list of. We're trying very hard to kind of make the task lists and all the opportunities to do cool work and to learn neat things. We're trying very hard to make that a little easier to find, so where you don't have to actually go through the entire Slack history to figure out what's going on. So we are trying to kind of up our game in the communications department there. So having a list that's kind of front and center and sent out regularly, I think will go a long way towards making it a little less intimidating to volunteer. Because, open source projects can be intimidating to get involved with, and we would like to reduce that down as much as we can. All right, so until next week, see you all on Slack. Please reach out if you need anything or have any questions, or if you have any ideas or know of a cool project that needs a home. All right, see y'all soon.